Assalamu alaikum everyone. I hope you guys are doing great. So in this class, we are going to talk about some more contents from the A2 Math syllabus. We were discussing trigonometry and today we'll be talking about the double angle formulas. So let's get started. Okay, so this is basically going to be the fourth unit. It's 3.4. Double angle formula. So let's get started. Okay. Now, basically, when the statement says double angle formula, that basically means that you would be having double angle. For example, sine of 2a is equal to 2 sine a cos a. Similarly, if we talk about another scenario, let's say we talk about cos with double angle means twice the angle. It is going to be cos square a minus sine square a. And if I talk about tan with double angle, so tan 2a is basically 2 tan a divided by 1 minus tan square a. So these are the three double angle formulas which we will be using in order to simplify questions. But before that, we will spend some time in understanding how exactly these formulas are derived, but not because the examiner would ask you for the derivations, but because in case if you come across something similar in identities, so there you'll have to prove this thing, okay? So let's talk about it. Now, okay, we know sine a plus b is equal to sine a cos b plus cos a sine b. This is what I know. So since I have sine of 2a here, I can think about it as sine a plus a, and this would give me sine a cos a plus cos a sine a. So I can clearly see that this term is just like this term. So I can write it as 2 sine a cos a. This is going to be the idea about it. Okay. All right. So yes, this is the first thing. Let's talk about another proof. Let's prove tan to a formula. So again, first of all, I'll write it down this way, that tan a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. And I can write down the same thing, tan a plus a is equal to tan a plus tan a divided by 1 minus tan A, tan A. So tan A plus tan A would give me 2 tan A divided by 1 minus tan A squared. So this is what exactly we wanted to prove. Tan 2A is equal to 2 tan A divided by 1 minus tan square A. So I know that this is going to be tan 2A, and I got the exact same thing. So this was just done to prove some of these double angle identities. But the basic idea behind this unit is to use double angle identities in order to simplify stuff. So let's talk about some questions now. Okay. Question number one. Question number one says, solve the following equations for 0 degree less than equal to theta less than equal to 360 degrees. Part A says 4 sine 2 theta is equal to sine theta. Okay. Let's talk about the solution. Now I know in order to solve any trigonometric equation, I need to have one trigonometric function only. Well, in that case, some of you would say this is sine, this is also sine. So ideally the two trigonometric functions are same, but the issue is that this is with 2 theta and the other one is with theta only. So they are not same, okay? We are going to use the double angle formula for sine 2 theta and then solve this. So instead of sine 2 theta, I will write down 2 sine theta cos theta equals sine theta. Now, if you guys think that at this point I am going to cancel sine theta with sine theta, that's very, very wrong. This would end up giving you less number of solutions compared to the actual number of solutions, right? We know that if I take the sine theta on the other side and then if I take sine theta common, I would get two equations. But if I cancel sine theta and sine theta, I would only get one equation. So since by canceling, I would not get the other equation, so I would not get the solutions I would have, gotten using the other equation. So always remember, you are not supposed to cancel the variable in any equation. So this is going to give me 8 sine theta cos theta minus sine theta equals 0. Now I can take sine theta common and this would give me 8 cos theta minus 1 equals 0. And finally, it is sine theta equals 0. This is the first equation. And 8 cos theta minus 1 equals 0. This is my second equation. So I can just simplify this thing now. And after simplifying this, I can write it as theta is equal to. Now you guys need to think when exactly is sine 0. For that, the best way to understand is to make the sine graph. So this is how the sine graph is. This is 0, this is 180, and this is 360. So it's 0, it's 180, and it's 360, and all these three angles are lying within this range. So these are correct. And if I talk about the other one, so cos theta is equal to 1 by 8, it is positive. I'll talk about the quadrants now. So it's the first quadrant, the second one, third, and fourth. Cos is positive in the first quadrant and in the fourth quadrant. So first of all, we need to talk about the basic angle. So theta or alpha is going to be 82.8. This is going to be in the first quadrant. This is 82.8 degrees. And for the fourth quadrant, the angle is going to be this one. So it would be 360 minus 82.8, and that would be 277.2. So theta is equal to 82.8 and 277.2 degrees. This is going to be the answer. Okay. All right. So this was the first question, and in the first question, we were supposed to solve the equation, and in order to solve the equation, we just used the double angle formula thing, and we were able to do it correctly. Okay. Let's talk about the next question. Part B of the same question. It is cos 2 theta equals cos theta, and this part is same. This is 0 degrees and this is 360 degrees. Okay, this is what we need to do. So cos 2 theta is equal to cos theta. Again, I cannot say that cos 2 theta and cos theta are same, so I can solve it. No, I need to first simplify it and convert it. I know that cos 2 theta was basically equal to cos squared theta minus sine squared theta, and I know that sine square plus cos square was equal to 1. So sine square would be equal to minus cos square plus 1. So cos 2 theta can be written as cos square theta minus, and then instead of sine square, I'll write down minus cos square theta plus 1, and this would give me cos square theta plus cos square theta minus 1, and finally 2 cos square theta minus 1. So this is what I would get. So I can write down cos 2 theta as 2 cos square theta minus 1. I can use this idea and I can say that cos 2 theta is equal to 2 cos square theta minus 1, and this is equal to cos theta. Now I can say that technically both the functions are same. So I am in the position to simplify it. So I'll just take everything on the left side. 2 cos square theta minus cos theta minus 1 is equal to 0. I need two numbers such that when I multiply them, I get minus 2, and when I add them, I get minus 1. So it's going to be minus 2 cos theta and plus 1 cos theta minus 1 equals 0. So I can take 2 cos theta common. This would give me cos theta minus 1. Plus I can take 1 common, and this would give me cos theta minus 1 equals 0. And finally, the two factors are going to be 2 cos theta plus 1 into cos theta minus 1 equals 0. And this would give me cos theta equals minus 1 by 2 and cos theta equals 1. And now we need to talk about the quadrant stuff. So this is my first equation. This is the second equation. Let's talk about things according to the first equation for now. So theta is going to be, okay, now I know that it's -1/2. That is giving me 120 degrees. But is that okay? That's not okay. I'll tell you why. It's not okay because this is negative. This is the first quadrant. This is the second quadrant. 180 degrees is basically an angle in this quadrant, and this is basically 180. The idea was not to find out 180, but to find out the basic angle, and that would be 60. Okay, so the basic angle is 60. Now we know that the basic angle is 60 and cos is negative in the second quadrant and in the third quadrant, and this angle is also going to be 60, and for the third quadrant it would be all the way from here to here, so it would be 180 plus 60. So theta would be 120, the angle in second quadrant, and 240, the angle in third quadrant. Now let's talk about this. Cos is positive now, so first of all I need to find out the basic angle, and that is 0. I need to see when exactly cos theta is 1. So for that, it's better that I go for the graph rather than talking about the quadrant stuff. So let me make the graph. In that case, this is the graph. It's 1 at this point, this is 0, and it's 1 at this point. This is 360. So that is 0 degrees and 360 degrees, and all of them are in the range, so this is going to be the answer. So we need to be precise about what exactly we are calculating and what exactly the examiner has asked us to calculate. Okay, all right, let's talk about another question. This is basically a past paper question. Okay, the question says, express cos 3 theta in terms of cos theta. Okay, you've been asked to express cos 3 theta in terms of cos theta only. So this is basically the challenging part. So we know that we can write down cos 2 theta in terms of cos by doing some extra steps, but we are not too sure about cos 3 theta. So for this, we need to use both the uh, units that we have discussed before this one. Okay, all right. So let's talk about. In order to prove this, we know that cos 3 theta can be written as cos 2 theta plus theta. This is what we know. Now I can write this thing using the angle formula. It would be cos theta minus sine 2 theta sine theta. And finally I can write this part as cos squared theta minus 1. This is what I have just proved in the beginning of, not in the beginning, but before the previous question. We have just done this part, and then this is cos theta minus, and I can write down sine 2 theta as 2 sine theta cos theta sine theta, and this would give me cos cube theta minus cos theta, then minus 2 sine squared theta cos theta, and finally cos cube theta minus cos theta minus 2, and then cos theta, and instead of sine squared theta I need to use the idea that sine squared theta plus cos squared theta is equal to 1. So sine squared theta would be 1 minus cos squared theta. And now everything is in terms of theta. I am just supposed to simplify it. So this would give me this was 2 here, and this would be 2, this would be 2, and 1 second only. So finally I would get 4 cos cube theta minus 3 cos theta. This is going to be the answer. So again, we were asked to express cos 3 theta in terms of cos theta. I know that cos 3 theta can be written like this, and I know how to deal with cos A plus B. So I assumed that this was A and then this was B, and I've just, expanded it using that. And then I have further used cos 2 theta or the double angle stuff. Like sine 2 theta can be written as this part, and then sine and sine would make it sine square theta. And then I've used this basic trigonometric identity, and after using everything and simplifying, I was able to write down cos 3 theta as 4 cos cube minus 3 cos theta. So this is basically how we represent cos 3 theta as 4 cos cubed minus cos 3 theta minus 3 cos theta. Yes, okay. So this was basically the discussion in this chapter, and I hope that you guys were able to understand everything. Let me just scroll up. Okay. So we discussed 3.4 today, where we talked about double angle formulas. And initially I just wrote what exactly sine 2a, cos 2 and tan 2a looks like, and then I proved for sine and tan. You can always do that for cos as well using the same idea. Then we discussed the first question, where we had to solve trigonometric equations, and we had the range as well, and we were able to solve that very easily. And after that, this was the past paper question that was basically an identity question. We had to show that cos 3 theta can be written as cos theta, and we were able to do that using multiple identities. And after that, I was able to write down cos 3 theta as 4 cos cube theta minus 3 cos theta. So if you guys have anything, if you have any difficulties, any confusions, feel free to ask me using the link in description, or you can directly comment in the comment section to ask questions, right? Take care all of you, and Allah Hafiz.